Yeah, here's the board. I'm gonna have to snap a few photos. There's a big giant start capacitor for the compressor. That little blue box up here looks like it could be a relay. I got the schematic and it's labeled on the board. I'll figure it out. Transformer down on the bottom for running the front board. Yeah, there you go. It's gonna be fun. I gotta snap some photos so I make sure I get the wiring all correct by the colors. It'll help. All right, man. Peace, love, half a heart. I don't have half a heart. I don't have any fingers loose right now, so I will see you later. Hey, this is Ronnie. There's what's left of the box. I got the board out. There's the wires, other wires. The little that's a 12-volt transformer. That's a giant capacitor that starts the compressor. And then down there is another capacitor. I can't remember if that's the one for the fan. Those wires are for the 3-speed fan. Blah, blah. I got them marked. I taped them off too, and I took pictures. Yeah, and here's the board. Uh-oh, where's my cigarette ashtray at? Oh, right there. Here we go. Yeah, I know smoking's bad for you. Everything's going to kill you. There's the little board out. Okay, I said there's a schematic on the outside of the box, but that just shows the main box wiring. It does not show the PCB schematic. But, gotta be smarter than the average Barry. I knew it had to be a pretty big freaking relay. And if you follow it, I did kind of follow the wires. It does show on here, where was it now? Fan motor capacitor, compressor. Right here shows the compressor, then right here. RY7. Right there. The RY7 is relay number 7. That's in line on the black wire from the power lead coming in. Which, doing some searching, that overall relay is optional. I don't know if it's on here or not. I didn't go that far. I found my relay. It's this guy. These 3 here are relays for the different speeds of the fan. This is your main brain box. That transformer is 12 volts. This board runs off of 12 volts, okay? That's why the control panel, the LCD control panel and all this runs off of 12 volts. That's why it has to switch to 120 for the fans and for the compressor, okay? And this is normally open when it's powered off. And then when you turn on it and it decides it needs to cool, the compressor will turn on. A computer chip brain here will tell this guy in 12 volts. It's got 4 pins on the back. Right? Where are we at? Right here. 1, 2. There's your mains, and there is the coil. 12 volt coil one is right here. Okay? Those 2 are 12 volt coil. That pulls the relay. That's the hot jumps across. Alright. So, that's the puppy. And before I even pulled that board out, I took my meter right here, because these relays, I said it had been working, then it didn't, then it did, then it didn't. You take your meter, you put it on ohms, and I went, and if it was bridged across, stuck, it's supposed to be open. If it was stuck shut, not powered, your meter will show some resistance. It'll show continuity between the pins, and it did when it was in the board. In the box. Once I got it out of the box, that's why if you got something going wrong, you test it. Try to find it before you even remove it. If I can try to do this. Come here. We're gonna stuff this guy in here. I'm gonna have to hold this with my freaking teeth or what? Let me try this here. Shove these together now. Okay, I got them both on that relay now, and look what the meter's showing. Nada. No conductivity between it. That means it popped back open again. I said it would work sometimes and then it'd hang up and stick. And if you do take and just tap on the side of these damn things with this little screwdriver or something, when they're powered off, they'll usually pop. But it'll keep doing it. It's going to keep sticking until it finally just melts all the way together. I looked online. Like I said, it did show, like my meter here when I did it before, it was showing a little more than that. It was showing about 1.2 ohms because of the resistance going through the frickin' pins and stuff inside. But yeah, there you go. Oh, you know how a relay works? I had one drawn up from before if I could find it. Here's how a relay works, how that little box works, okay? Let's see here. Okay. This doesn't matter because that's for with an opto-isolator solid state, and you can't get a solid state. When I looked them up, I can't find a solid state. But here's what it is. The 2 pins on top, okay? 2 pins on top, where those are right here. That's 110 volt hot coming in, and then that little switch, the points are open, and then it goes out. And then the bottom underneath the board where it shows the 12 volt rail right here and here through the pins, that is a coil, and it has a plunger and makes a magnetic current. When the computer chip says we need to turn that compressor on, it can't handle switching all that, so it just runs 12 volts through that coil inside of here on the bottom. It will magnetize it, which pulls. It's got more moving levers and shit than this, but when it juices up, 12 volts runs through here, it will pull that shut. And then you got your 120 at 20 amps running through that. This can maybe pull probably 0.5 amps. I think the rate at 0.3 amps is what they'll draw. There is no way, the switch would have to be so freaking big, you know, and off of 12. So that's why they use relays. And then when it says it's time, it's cool enough and the compressor can shut down and then the fan keep running for a while, it will cut the power to that coil, which will let that, is spring loaded, there's a spring and it will pop it back up. And then when it says we need more cooling, turn the compressor on, it will power up, that chip will power up through the board, that the 2 pins that run the coil, that again pulls this down, and then you got your connection. It's just like a little tiny switch flipping a great big switch, okay? That's what it is. That's how a relay works. Basics, that's the basics. But yeah, that guy right there, I tried to find a different brand. Made in China. I got a couple coming from shipper on eBay from I don't know where, here in the United States, supposed to be here in a week. I would like to have a solid state. A solid state relay. Here's the problem with these regular relays. This is what 120 volts AC looks like on this line right here. 12 volts DC, it would just look like a straight line on an oscilloscope, like this black line. AC changes from forward to backwards 60 times a second on 60 hertz. Okay, we're on 60 hertz. So, 60 times a second, it goes through 0, okay? There's no voltage. And then you're at 120 volts high, then it reverses 120 volts the other way, passes through 0 voltage every 60th of a second. And a solid state one, or something with an opto-isolator, they call it in it, it will only, even if this power's on, it will only let it trip these points when this power on the line is 1/60 of a second at 0. Okay, so there's no voltage, no amps, nothing going through those points. So they will run forever, or else they can switch that with a little computer chip too, but they're bigger, they don't make them this size. I guess it's cheaper, they don't want to play with it. But you get my point, you know, if it kicks and it's at the sine wave up here at a full 120 volts and then it hits wide open to pulling 20 amps, that's a lot of pressure on a little tiny frickin' deal that's about the size of, the points might be the size of the end of that push button on my pen. Not even that big, probably, or a little smaller than that. And yeah, at 120 volts, it's pulling full 20 amps when it loads it up. That's why they get going and they spark and they burn together and it melts them. And opto-isolator solid state relay, zero switch relay, it's got a little brain box and opto-isolator and that will not let those points connect until there's 0 voltage, so there is no way they can spark or melt or anything. That's why solid state lasts forever. But these were from China. There are 10 of them for $6 because they're made in China. But I had to pay $10 for 2 of them because I didn't want to wait with my air conditioner all torn apart for 3 or 4 weeks to get them. But yeah, there you go. I'll show you when I get it back together, it'll work. But yeah, the minute you move and tap these and bang it around a little bit, there you go. She popped back open, but it's going to keep doing that, and I don't feel like unplugging it and plugging it in. Well, I got time, and I said I got 2 of them coming. because after, well, that thing lasted 2 years and it took a crap, and I can only get this brand. It's a special one that only fits this board. So yeah, there you go. So you got your coming and going on that. But yeah, that's the scoop on the relay. And how I could tell, you know, even by here, it shows the deal. But if you look right beside on the schematic, is kind of printed on the board. The board does have printing on it, and I don't know if I can get the focus, you fuck. Right on the left side there, it says RY7 COMP. That's relay number 7, compressor. And it shows right there on the schematic, because it's the big wires, RY7 coming from, I know it ain't focusing, from the compressor direct through the black line, which is a total hot all the time line, back to your power out of your wall, which is odd. Usually you'd think they'd switch to neutral, but this is switching the hot right off the hop too. So yeah, but there you go. That's how it works. I just got to have to take it off the desolder, the 4 pins from here and here, and suck the solder off and pull them out, clean it up, and then solder a new one in. Beats $140 for a whole board. When I wonder how many of those they sold. That's probably why they're sold out for boards, except if you can lucky to find one for $140, nobody knows how to fix them. But that's all you gotta do. You know, you got time to play with it. There's no shit stains on anything else. I said everything was working, the fan speed, everything, except the compressor would not shut off, and that's got to be that guy right there. Okay, man. Maybe I'll show you how I take it apart when I get it and fix it. Good to go. Love, half a heart. The sun's out today. I got to do some more working on stuff yet, but yeah, there you go. Half a heart, peace, love. You know, you fix stuff if you want to play with it, there you go. But like I said, make sure it's out of the wall. Unplugged out of the wall. It's 120 volts. You get whacked. 12 volts will whack your ass real good if you don't watch it. But yeah, you want to play around with stuff like this, yeah. Don't be playing around with it when it's plugged in. You hurt yourself real bad if you don't know what you're doing. And no user serviceable parts inside that AC unit, if you can tell. But, you know, what the hell. I'm an electronics guy. I can figure that shit out. Yeah, there you go, man. Y'all have a good one. Like I said, I'll make a video of it. At least test running it. Or maybe just soldering that in to show people how that works. And, you know, like I said, I labeled all the wires and just change this out. And then put it back in and hook all the wires back up. And theoretically, it should be good to go. Theoretically, you know, if I fuck it up, I fuck it up. But I said that I knew it was going to be simple. So hopefully that's it. I said everything else is working. I'm about absolutely positive because it was stuck and now it's open. That's what the problem is. All right, man. I'll be back. I said I'll make a video in a few weeks when my parts come in and I put this back together. Maybe you can learn you something. All right, y'all have a good one. I love y'all. I will see you later. Ciao.